Good day and welcome to my YouTube channel. I am Arthur Francis Diban. Today we're going to be taking on the hydrocarbons, which is an integral part of organic chemistry. Hydrocarbon is the study of hydrogen and carbon, respectively. Then, in the hydrocarbon, we have classes like it is divided into aliphatic hydrocarbon, aromatic hydrocarbon, and so on. In the aliphatic, we deal with the straight chain and the branch chain. The benzene ring falls under the other one, and so on and so on. But the major objective today is to deal with the alkane side, which is the aliphatic. How do we write the molecular structures, the formulas therein, the reactions that are associated with it, and so on and so forth. As time goes on, we're going to proceed further to knowing how to name organic compounds, which is very important. In short, it is very, very important. So, in the hydrocarbon, like I said, the alkane generally, we're going to look at their general molecular formula. Then we look at the classes. Then before we can now proceed. So let's take, for example, in the aliphatic, which I say alkane is the pivot, which we are concentrating on. We have the alkene, we have the alkyne. But let's take alkanes, for example, which we have a general molecular formula of CnH2n plus 2. With this formula, we can name all sorts of alkanes. We have methane, ethane, propane, butane to decane, which is 10. But how will you know if you're dealing with 8? First, you must know the serial order of the naming, of the nomenclature. That 8 is what? Octane. 7 is what? Heptane, and so on. Now, how many carbon atoms are there, or hydrogen atoms are there in octane, or in heptane, or in hexane? Now, this formula, the CnH2n plus 2, will help you to know exactly how many carbon and hydrogen atoms are there therein. Let's take, for example, pentane, which is 5. Alright, using the formula here, I can easily say C5 for the N is the number which we are proceeding, which pentane is 5. So this becomes C5 H2 times 5 plus 2. Now I have my C5 H2 times 5 is 10 plus 2, 12. So this becomes H12. So this becomes our molecular formula for what? Pentane. Through the aid of the formula here, the general molecular formula for all alkanes, we can now proceed to deal with either propane, butane, and so on. So if this is the molecular formula, the structural formula therein, remember alkanes have this catenation. The link, the bonding between carbon and carbon is called catenation. So if I want to name it, I have 1, 2, 3, 4, 5. Don't forget that carbon is tetravalent, which means that it must have 4 substituents surrounding it. It mustn't have more than 4. If you have this as your carbon and you have this and this, let's put it this way, you should know that this is wrong because the number of bonds associated with the carbon are more than 4. Carbon is tetravalent, which means this becomes the original or the true formula, which is C, H, H, and H, which makes it 1, 2, 3, 4. It has to be 4. So, to that end, if this is my pentane, so remember I have to put the 5 hydrogen atoms because from the formula here it says C5, 1, 2, 3, 4, 5, H12. So if I put my hydrogen surrounding it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So this is correct because the number of hydrogen atoms are equivalent with the carbon atom. So let's look. If we say carbon is tetravalent, which means it must have 4 bonds surrounding it. This carbon atom has 1, 2, 3, 4. This one has 1, 2, 3, 4. This 1, 2, 3, 4, and so on and so forth. There should never be a case where you have 5 bonds enclosing 1 carbon atom. Mostly when we get to the alkene family, you see things similar, and students make a whole lot of such mistakes. You will see when we get there. So the first one we took as an example is the pentane. Let's take another example. Propane, for example. Propane means 3. So this is the formula. Means anywhere I see N, I put 3. So I will come over here and say C3 H2 times 3 plus 2. C3 H6 plus 2, 8. So now the structural formula, this is the molecular formula. The structural formula becomes 1, 2, 3. 1, 2, and 8. So if I put my 8 hydrogen, 1, 2, 3, 4, 5, 6, 7, and 8. And so on and so forth. So with this, now we can easily write out the structural formula for any member of our cane. Let's take the cane, for example, which is 10. So this says CnH2n plus 2. So this becomes C10 H2 times 10 plus 2. C10 H2 times 10, 20 plus 2, 22. So the structural formula would therefore become this. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have my 10 carbon atoms. My hydrogen now become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. So one of the most important things you must know and take into cognizance is the number of the first 10, let's put it that way, of the alkane family, which is methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. If you know that your first 10 falls within that rate and their numbers, then you can now use this formula perfectly. But if you do not know that propane is 3, then how will you know where to put what to put in the place of N? Because you do not know that it is 3, then you don't know the exact value to put in there, and that will become a problem. So it is imperative that first thing first, we must know the first 10 members of the alkane family, have it in our head. Then when I say hexane, you know it's 6, octane is 8, nonane is 9, methane is 1, and so on and so forth. So methane is 1, so this becomes C1 H2 times 1 plus 2. C, that is 1C now. H2 times 1 is 2 plus 2 is 4. So CH4 becomes our methane, and this is base. So ethane, the same thing, which is you put it and know how many hydrogen atoms. If you do not know the number of hydrogen atoms, you will not know how to draw your structural formula. So if I may ask you that, draw the structure of propane. First thing first, I know the general molecular formula CnH2n plus 2. Second, I know that propane is the third member of the alkane family, third. So if I put it into the formula, I'll have C3H, how many? 8. So by that, you can easily draw your structures and put your hydrogen atoms. We are going to get into numbering, but until then, numbering or naming of organic compounds. When we get there, you see the intrinsic factors associated with it, how interesting it is when we understand the rules. We must follow the rules in naming of what? Organic compounds. But then let's proceed further. Now we're going to look at the classes of the hydrocarbons. Now, the classes of carbon atoms, we have the primary, the secondary, the tertiary, and the quaternary. These classes are very paramount. Now, I'll give you a practical example. So I say primary, secondary, tertiary, and quaternary. So, if this is my carbon atom, okay, let me draw a compound. From it, I will illustrate the primary, secondary, tertiary, the ring, and we'll take some other examples. By that, we'll complete our definition. If this is a compound, okay, Now, let me put my hydrogen. I use this structure to define the various classes. We'll talk about primary, secondary, and tertiary. Now, here, this carbon atom is attached to one other carbon atom and 3 hydrogen. Let's listen attentively, it's very important. Now, I want to name my primary, secondary, tertiary, and quaternary. So when a carbon atom is attached to only one carbon atom and 3 hydrogen, it is primary. Primary, 1. It is attached to one carbon atom. Let's take that. If you say primary, that's 1, 2. Secondary, 3. Tertiary, 4. Quaternary, alright? So we'll use the carbon situation to define what we're looking for. We'll say primary carbon. Remember, we're talking of carbon, classes of carbon. Now, primary carbon is a carbon that is associated with one other carbon, that is linked with one other carbon, and 3 hydrogen. If you want to put the 3 hydrogen, but the most important thing is it is attached to one carbon atom. So I can put 1 here and call that primary. Now, we move down to, okay, let's take this is 4. I call this 4, this is quaternary. A quaternary carbon is that carbon that is attached to 4 other carbon atoms and no hydrogen. This carbon is attached to one carbon, one carbon, one carbon, one carbon. So this, I put 4 in there. It is quaternary. I will want to take this a little further so I will get them all complete. Another hydrogen here. Now, tertiary carbon is that carbon atom that is attached to 3 carbons and 1 hydrogen. But now, I don't think I have anyone that is here. But let's look at, okay, yeah, this is tertiary, 3. It is attached to 3 carbon atoms, 2, 3, and 1 hydrogen. That is tertiary carbon. Now, secondary carbon is attached to 2 carbon atoms, 2 carbon atoms, and 2 hydrogen. So, by definition of the classes of carbon, yeah, I said earlier on, when we say the primary, secondary, tertiary, and quaternary, the primary carbon is attached to 1 carbon atom only. If you like, put it and 3 hydrogen. Fine. Secondary is attached to 2 carbon atoms, tertiary 3 carbon atoms, quaternary 4 carbon atoms. So I will write a structure where we are going to use it as a question to see how we answer it to get what we are looking for. But by virtue of what we have here on the board, I've been able to explain to us what a primary carbon is. A primary carbon atom is attached to only 1 carbon and 3 hydrogen. Secondary, 2 carbon and 2 hydrogen. Tertiary, 3 carbon, 1 hydrogen. Quaternary, 4 carbon and no hydrogen. Why do we have to add the hydrogen therein? Because each carbon is tetravalent. So if it is attached to 1 carbon, what about the other 3 bonds that are associated to carbon? So the other 3 bonds are hydrogen bonds. So that is that. So by definition, a primary carbon is attached to 1 carbon atom and 3 hydrogen. Secondary, 2 carbon and 2 hydrogen. Tertiary, 3 carbon and 1 hydrogen. Quaternary, 4 carbon and no hydrogen. For example, this carbon is quaternary. It's attached to 1 carbon, 1, 1, 1, 4. And there's no hydrogen. It's not linked to any hydrogen. Tertiary is linked to 1 carbon, 2 and 3. 1 hydrogen. Secondary is linked to 1 carbon, 2 carbon, 2 hydrogen. Primary carbon is linked to 1 carbon and 3 hydrogen. Primary, 1, 3 hydrogen. Primary, primary, primary. So, by virtue of that, we understand what we are dealing with. The primary, secondary, tertiary, and quaternary word, carbon, as the classes of what? Carbon. Let's take a question. Okay. Let's take a question. Now, in the question here, we have to identify primary, secondary, tertiary, and quaternary word carbons before we move further into other reactions. Now, it is important we note something. When we're dealing with naming or this carbon stuff in hydrocarbon, when we put our carbons, we put our hydrogen. But it is also imperative we know At least at the A level, you should know that whenever you see carbon, you should have it in mind that there are hydrogen associated with it. Unless we have to go back to our secondary level, which is the high school level, where we have to show how the hydrogens are all associated. If I have this, I don't need to be told that this is propane. It is the same thing when I put my hydrogen here. Hydrogen. Now, at the A level, it is not wrong to write it as this. Or as this. 1, 2, 3. This is the same thing as propane. But now we have various ways. We have the condensed formula method, we have the zigzag formula method, and so on. So, we will not talk about, let's leave all this. We can look at this and the condensed and this elementary method. Now, wherever you see your 3 hydrogen, have it in mind that there are, you see your 3 carbon atoms, have it in mind that there are hydrogens attached to it because carbon is tetravalent. If we have to be writing the hydrogen, yes, we can do that. It may take us time. Like, for example, if I want to put all the hydrogens therein, it may take us time. But maybe for the sake of emphasis, let me just put the hydrogen and see what we make out of it. But before I put the hydrogen atom, from here, you'll be able to also know and identify the primary, secondary, and tertiary word carbon. We say a primary carbon is bonded to one other carbon atom. So this guy is bonded to just one. So I can give him 1. This guy is bonded to 4. 1, 2, 3, 4. I give this guy 4. This one to 1 carbon. This one to 1 carbon, which is this. This one to 2 carbon. 1, 2. This one to 4. 1, 2, 3, 4. This one to 3. 1, 2, 3. Tertiary. This one to 1. This one to 1. That's 1. This one to 3. 1, 2, 3. Tertiary. This one to 4. 1, 2, 3, 4. Quaternary. This one to 1, which is just this. This one to 1, which is just this. This one is 2. Secondary. This is primary. This is 2. Secondary. 1, 1. This is primary. This one is bonded to 1, 1. So I give him 2. This is 1, 1, 2. This is just 1, 1. So by virtue of this, you can easily look and know the carbon that is primary, that is secondary, that is tertiary, that is quaternary, based on the bond linking. Is it bonded to 2 carbon, secondary, or 3, tertiary, or 4, quaternary, and so on and so forth. So by virtue of this is what we can get on alkanes. The general molecular formula which we can use to elucidate the structure of that molecular of that compound you want, or let me call it propane, butane, hexane, or whatever it is. If it is hexane, you know you're dealing with 6. You can easily put in a general molecular formula CnH2n plus 2, and you'll be able to get your carbon atom and the number of hydrogen atoms, and you arrange them. And also important, you must know that the aliphatic doesn't necessarily mean that it must be straight chain. It can also be branch chain. If I have this, all this is the same thing as 1, 2, 3, 4, 5, 6, hexane. It mustn't be 1, 2, 3, 4, 5, 6. It mustn't be straight chain. So without the hydrogen, you should know, count the parent chain, how many of them? There are 6. You name it. 6 is what? Hexane. When we get to where we deal with substituents and naming of various compounds, then you will also understand. So let us proceed further. Let me see. Okay, the rules for IUPAC nomenclature of alkanes. Before we get down into the rules, there are a whole lot of rules. I will take my time to deal with the rules. But then, let us look at some reactions of alkanes. Some of the basic reactions which alkanes undergo, but others doesn't. And when we get to alkenes, we also see the reactions they undergo, and alkanes doesn't. So, aside isomerism, which all of them will undergo isomerism, we have the 2 basic, which is substitutional reaction and combustion reaction. Combustion is where the alkane react with what? Oxygen. While substitution reaction majorly happens with the halogens, could be bromine, chlorine, fluorine. So we'll do one of them, example, and see how the others will play out. All right, let's take one here, methane reacting with oxygen in combustion reaction. Let's see. The first example or member of the alkane is methane plus oxygen. What do we get? We're going to balance it. So when you do that, you have to know what and what you get. Is it water, CO2, and in what rate? So if I have my CO2 plus water here, we have to now check. How many carbon atoms do we have? We have one. We have oxygen here, 2. We have oxygen now, 3. So if I put 2 here, I have oxygen 4, and I put 2 here, I have oxygen 4. So by virtue of this, I said my equation is balanced because carbon is 1, 1. Oxygen is now 4. 2 plus 2 is 4. Hydrogen is 4, which is 2 times 2 here, 4. So by virtue of that, we say the equation of reaction is what? Balance. That is what? Combustion reaction of what? Alkanes. So let's look at substitution reaction. In substitution reaction, we say it reacts with what? Halogens. Let me check the basic rules. But then, we can still use our methane reacting with chlorine, yes, and see what happens. Chlorine gas. Okay? So let's go down to substitution. I have my CH4 plus Cl2 in the presence of light or heat. Let's put it that way. Now, in substitution reaction, it's just like in football. When you play ball, they say you substitute. One of these guys will be moved to join this, and one of these will be moved. Now, what is left? If one hydrogen is out, let's take this guy. One hydrogen is out, one chlorine is out. What is left here is one chlorine and CH3. So I have my CH3, what is left? Alright? Then one chlorine that is left here, I bring it down. This is chloromethane. And the other guy that left will now become HCl. So we are substituting. We are going to carry out the process gradually till we get to the end and see what we get. So now, if this is what is left, we continue to substitute until we get to the end of this. So now, if I bring out this, my CH3Cl, which is my chloromethane, plus another Cl2, having the same state in the presence of ultraviolet light. Now, one hydrogen will move again. When this one hydrogen moves, I will be left with CH2. CH2. Now, that hydrogen, let me put the hydrogen. This is where the hydrogen is. Now, this chlorine is here already, but this other bond, remember one will go to join the hydrogen and one will come down here. This other chlorine that comes here, 2, which I was having, okay, this is 1, one other chlorine becomes 2. And the chlorine comes here. So we have dichloromethane. We continue to replace. If I go further, another hydrogen will move out. Another chlorine will join. I will have CHCl3, on and on. So now, I have my CH2Cl2 plus Cl2. If this goes, now this is what I have. One hydrogen will go, I will be left with CH. I have 2 chlorine here. One chlorine will join it to become Cl3. Now that is fixed. That hydrogen that moves over to join the leftover chlorine will give us our HCl. I still have hydrogen. I'm substituting for the hydrogen continuously till I exhaust them all. Now the next one, I'll bring this trichloromethane, CH Cl3 plus Cl2, and this will give us This hydrogen will now leave. I will be left with no more hydrogen. So I have C, no H. I was having Cl3. One chlorine will come now to give me Cl4. That hydrogen that leaves will come down here to give me HCl. So this is tetrachloromethane because I'm having 4 chlorine in this methane compound. So this is a complete substitution reaction which happens with the alkane family. When we get to the alkane family, realize there we deal with something else, which although all of them will undergo combustion, but the other one will become what? Addition, what? Reaction, no longer substitution reaction, which is the basic difference between the reaction of the alkanes and the alkenes. Alkane undergoes substitution, while the alkenes undergo addition. So you will see when we get there. So this is the preliminary state which we have to take this. If you have this in your head, you can easily draft out what happens to the rest. What if the methane decides to react with bromine? Let us see how we're going to do that. Alright? Of substitution reaction with bromine. So I have my CH4 plus bromine molecule here. Now, in substitution, these 2 bromine, one of it will come and take 1 hydrogen. And 1 hydrogen will meet the other bromine. That's all, to give us hydrogen bromide. So let's assume 1 hydrogen has left. We now have CH3. Now 1 bromine here will come over here to join this, okay, to give us Br. What is left? The hydrogen that left, this is the hydrogen. The bromine, remember there are 2. The other one will give us Br. So this is our first step. Then the second step, I will bring this bromomethane to undergo the reaction again. I have my CH3Br plus Br2. This will still give me. Another hydrogen will move. We are doing substitution. Another hydrogen will move. I will be left with CH2. 1 Br. So when that Br comes, the Br becomes 2. So I have CH2 Br2. Now the hydrogen that left, this is it, and the bromine left is this. Okay, now I move further. The bromomethane will come over again. I have CH2 Br2 plus Br2. 1 hydrogen will leave again. I will be left with CH Br2 plus the bromine that comes here give you Br3. Are we together? Now we have hydrogen bromide again. Hydrogen bromide. Now we bring our base down here. I have CH Br3 plus my bromine again, molecule. Now we are substituting the last state, which is this hydrogen is going to be moved. Now I have C, no more hydrogen. I was having Br3. When one comes down, it becomes Br4. And the hydrogen here that moves, this is my hydrogen and the leftover bromine. This is tetrabromomethane. So by virtue of this, we have also done the substitution reaction for bromine. And this process can continue. We can still do the same thing with iodine. So that one would be, you can solve it and comment on the comment section what you get therein. Then we can now proceed. So let me just give you what you're going to do at your own private time. Comment in the send your answer at the comment section. I will say it. So we have the CH4 plus iodine molecule. The first step, I have my CH3, 1 hydrogen will go, and 1 iodine plus hydrogen iodide. So if you proceed with this, the next step, 1 hydrogen will leave, and we have 2 iodine. The third step, another hydrogen will leave, 3 iodine, another one, the last iodine will leave, hydrogen will leave, and we'll have 4 iodine, which is so on and so forth. So do it for your own personal aggrandizement. Let's put it that way. So let's move further. Rules in naming organic compounds. Okay, I think we should